Welcome to the KVP Physics Academy. Now next question, set A. Always memorize all questions from set A. Set A. Question number 24. ED questions. Okay, electrodynamics. Okay. A solid sphere of radius capital R. A solid sphere of radius capital R is a uniformly charged density. Uniformly charged density means a rho is constant. We can find out what is charge density at A, B and C. All points getting the same value. Means this one is uniformly charged distribution. Means we can change the distance. Density does not change. We can say this one is a uniform charge distribution. Okay. Now with the volume charge, volume is a 3D case. Okay. Rho, the magnitude of the electric field outside the sphere at a distance r. At a distance, how much? A small r. Okay. Now sphere is present up to here only. This one is a point where we can find out the electric field. Okay. Now we can draw the Gaussian at point P. Okay. Now what is the distance r from the center H? Okay. Now always memorize. Outside electric field is directly proportional to 1 by r square for spherical system. Whatever the electric density is varying inside, no problem. Density inside varying any form. This one is a uniform, non-uniform. Suppose the uniform, rho is constant. This is non-uniform, rho is directly proportional to r. Rho is directly proportional to r square. Rho is directly proportional to 1 by r. Rho is directly proportional to 1 upon r cube. Any type of charge density, but outside always memorize E out is equal to 1 by r square. Got it? Once you know the trick, definitely we getting the option directly find out. Okay, but we are going to in a regular methods. Okay, we know that here we can apply the Gauss law. We know the Gauss law is closed integral E bar dot ds bar is equal to q and close upon epsilon naught. Where is the electric field is a area vector, Gaussian area vector, and q enclosed. How much charge enclosed by this Gaussian surface? This is a very important. Now system is present up to here. Means charge is present 0 to capital R only. Not here charge is present. Here charge is equal to how much? 0. Okay. Now what is the electric field direction? Here is a charge. This one is a charge. Okay. Electric field always away from this one. Okay. Means this electric field is normal to the surface. Normal to the surface. Means electric field direction E bar is equal to ER cap. E bar is equal to ER cap. Okay. Now what is the area vector? This one is a sphere. What is the area vector? This one is the area vector. Means area vector also normal to the surface. Okay. Electric field direction. This one. Area vector direction same. Means both the vectors are in the same direction. Both vectors are in the same direction. Means angle between them 0. Okay. Means E bar dot ds bar can be written as EDS. Okay. Why? EDS cos theta. Angle between them 0. Why? Because they are perpendicular to the surface. Theta is equal to 0. Cos 0 is 1. EDS. Got it? Means integration EDS. Integration EDS is equal to q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Now we can draw this Gaussian at a distance small r. Okay, now we can find out the electric field at the point A, B, C, D. All points. Electric field is constant. Electric field is constant on Gaussian surface. Constant on Gaussian surface. This part, quantity is constant. Take common out. Take common out. ds. Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Now system is a sphere. System is sphere. We know that a spherical system area simply 4 pi r square. Okay, how much area is equal to how much? 4 pi r square. What is a small r? This is always Gaussian radius. Hence we can take the small r is equal to 1 by epsilon naught. Here no need to take integration. Why no need to take integration? Because all charge enclosed by this Gaussian. Okay, all charge enclosed by Gaussian. Hence we can take the rho is equal to q upon v. Means q is equal to rho v. How much charge enclosed? Total charge. For body charge, body radius is capital R. Then what is the body volume? Body volume 4 by 3 pi r cube. Okay, into rho means q is equal to simply rho into v. Why we cannot take an integration? Because whole charge enclosed by this Gaussian. Just to substitute this q value can be written as rho into 4 by 3 pi r cube. Pi r cube. Now this pi get cancel. This 4 get cancel. Okay. Now E. Here we can write down E out, no problem. R square is equal to rho r to the power 3 upon 3 epsilon naught. Upon 3 epsilon naught. Means E out is equal to simply rho r cube upon 3 epsilon naught r square, or simply out is directly proportional to 1 by r square 1 by r square. System is a solid sphere. Hollow sphere outside electric field is 1 by r square. Got it? Means which option is correct? Here option rho by r upon 3 epsilon naught. Electric field outside is not constant. Why? Because the distance is changing, power also changing. Means this option is not correct. Here D option also same. Yes, they are also given electric field is constant, but this one is not constant. Distance is changing, power also we know that changing. Okay, option number B and D are not correct. Focus on A and C. A and C. This also correct, but in which system? Inside the solid sphere. R is changing, distance is changing. At that time, electric field also changing. Why? Because number of charges is increases. Charges increases, field also increases. But this one is correct. But in which case? Inside the solid sphere. Inside the solid sphere. Got it? In SET exam, so many times they ask inside. Only one. This time they ask what is the electric field outside. So many people memorize what is the electric field inside. Rho r by 3 epsilon directly. This one is correct. After coming the exam, they are seeing your paper and what is the answer? Answer is C. Okay, alright. They are given answer is A. How? Actually, they ask what is the electric field outside. That's important. Outside electric field. Which option is correct? Option number A is correct.